Clipper is an electronic circuit, and in this circuit, what we do is we out of the input signals, we want to keep some part and give the remaining in the output. Then for that purpose, we use Clipper circuits. Now, basically, there are various types of clippers, but important clippers are, for example, one is a series clipper that you can see on your screen, right? In case of series clipper, I have told you earlier also, when your diode will be in series with the input signal, this circuit will be called as series clipper. For example, you can see it on the screen. Another name for the same circuit will be called as a negative clipper, because simply clipper means cutting. So in this circuit, your input is a full wave, and in the output your negative part is not there. So you can say that this is a circuit in which negative part of the signal is not there, otherwise it is a negative clipper. Fine. And we have discussed how it works. It is simply, it is as it is half a rectifier also, and we have already discussed how a rectifier works. But in brief, if you have to analyze how you get your output, we can divide the signal into two halves. One is positive half and another one is negative half. During positive half, this point will be positive and another point will be negative. And you know that during this time your diode will be forward bias, because P side of your diode is getting positive voltage and N side is getting negative voltage. And in case of forward bias, this diode behaves ideally as a short circuit, means for signal it is an easy way. Thus in the output, almost whole of your signal will be there. So whatever is in the input, same you will get in the output. But as far as negative half is concerned, during negative half, your diode voltage it is getting is opposite. It means P side is getting negative and N side is getting, of course, positive. In this case, your diode will be reverse bias. Reverse bias is like a very big barrier which stops flow of any current. Result is there will be nothing in the output. So this is how you get a signal like this, and this is called, in this signal negative part is not there, so we say it is a negative clipper. Is it okay? You understand this? Now if you will talk about another circuit, this is called parallel clipper, and the definition is when your diode will be parallel to the output, this arrangement of the circuit is called as parallel clipper. Now, if you see this circuit, then it will be called as positive clipper also. Why? Because in the input, you have got the signal having positive and negative half, but in the output, positive part is not there. Only negative part is there. So positive part is absent, or you can say it is positive clipper. It's very simple. Now, again, in very brief, how it works, we have to discuss step by step, because your signal has got two parts. We will start with positive half first. In case of positive half, this point is positive and this point is negative. Now your diode P side is getting positive voltage and N side is getting negative voltage. Thus your diode is forward bias. But here you have to be very careful. Earlier, when it was forward bias, your input signal and output signals were same, but this will not be the case here. In this case, your output is parallel to the voltage in a diode. Now, when a diode is forward bias, it is like short circuit or 0 volt. So, since diode and output is parallel and voltage in diode is 0, so output will be also 0 volt. And during the negative half, our input signal is like this. That is, it is negative and it is positive. In this case, your diode is reverse biased. If your diode is reverse biased, it is like it is not present in the circuit. So you have got a circuit having a closed loop in which your output is there. So how to know the output voltage? You have to put KVL, and as there is no current because your diode is reverse bias, here in the resistor current will be 0. So if you will use KVL in this loop, so you can say, if let us use KVL, and we will start from this point, plus sign is there. You can say plus VO, sorry, plus VI, or it is V. Now in the output, plus VO equals to 0. And what we need how much is the output voltage or how much is the VO. So we will keep VO here and take this voltage on the opposite side, will be minus V. So minus means our signal will be in the negative part of the axis. So this is how we are able to design a clipper. Now going back to this circuit, this is series clipper, but we have got a battery. You know, another name of battery is biasing. So another name for this circuit would be bias clipper. What do you mean by bias clipper? If you have got a battery in addition to the input signal, then we say it is a bias signal. Here is the input, and we have got a battery in addition to the input. So this kind of circuits are called as biased clipper. So let us see how much is the output voltage. Again, you have to be careful for some time to make our question easy. I will change, I will make a small change in the input signal. Your actual input signal is a sine wave, but I want to discuss with you first what will happen if your input voltage is a square wave. Let us make it 10 volt. Okay. So in positive half it is 10, and in the negative half it is minus 10. This figure is not clear, but I hope you are able to understand. So in this case, your signal has got two half. One is positive half, one is negative half. Let's talk about positive half. When we will use positive half, this terminal is positive and this terminal negative. In this case, your diode is forward bias. Why it is forward bias? You know, this is P side and this is N side. Now if you have got more than two voltages, you have to consider one by one. Now this P and your input is positive, means your input signal is making it forward bias. As far as this battery is concerned, this P and this battery positive means both of the signals are making your diode forward bias. Thus your diode will be forward bias. So how much is the voltage? We don't know. So let us put KVL. Now here voltage is VO. It means here also voltage is VO. Now how much is the voltage? Let us put KVL here. Let us start from this point. What is the input voltage? Input voltage is 10. So if you go from this point in the clockwise direction, in place of VI, we can say minus 10. Why it is minus? Because we got out at first minus, then this is minus 5, minus 10, then minus 5, then voltage in the diode is short circuit, so it is 0, plus VO, plus VO. These are all the voltages equal to 0. So VO will be how much? We will keep it on the left side, and all the other values we will keep it on the right side to simplify. It will be 10 plus 15, that is 15 volt. So in the case of positive half, when your input is 10, your output will be 15. That is all about positive half. Now, when you will consider negative half, the difference will be the input signal. Now, this will be negative, this will be positive, but there is no change in the battery because this is fixed. Now again you have to consider all the signals. Your input signal is making it reverse bias and battery is making it forward bias. So you have to see which one is big. Your input value is 10 volt and battery value is 5 volt. So input value is bigger and making your diode reverse biased. It means your diode is reverse biased. If it is reverse biased, it is like open circuit. It means your signal cannot go on the right side, that there will be nothing in the output or output will be 0. So for input 10 and minus 10, your output will be 15 and 0. Hope it is clear. Is it okay? You understand? Your output will be 15 for positive half, but for negative half, it will be 0. This is the discussion assuming your signal as a square wave. But now we are coming back to the actual question. And now in this case, your signal is having positive half, but it is not fixed. In case of square wave, your value of the signal was fixed, but here it is always changing. So it is from 0, it is going up to 20, and again it is coming down 0, minus 1, 2, minus 10, minus 20, then again going towards 0. So let us make a point here. Our battery is 5, so let us find a point where it is 5. So this is the place where your signal is 5. Okay. Now, your during positive half, you know this will be plus, this will be minus. Your battery is fixed, and your diode, this is P side, this is N side. Now in this case, both of the signals, whether it is battery or input, are making your diode forward bias. So thus your diode will be forward bias. As it is forward bias, your it is like a short circuit and it will be easy current. Now how much is the output? Like previous example, since your resistor and output are parallel, we will say even this is VO and we use KVL in this loop. Let us write KVL. It will be minus VI. Before it was fixed 10, but it is not fixed. It is VI. It is changing. Okay. Minus 5 because this battery we will get at first minus terminal. Plus VO. We are putting KVL in this loop equals to 0. So what we want how much the output. VO will be how much? Keep everything else on the right side. V minus VI will be plus VI, and minus 5 will be plus 5. So nothing. So thus your output will be input plus 5. Now you have to be careful. See this point. This is your positive half, and the solution is for the whole of the positive half because during positive half your diode is forward biased. Now when your input is 0, your output will be 0 plus 5. You have to use this law. When your input is 0, your output is 0 plus 5. When input is 1, 1 plus 5. When your input is 20, the maximum value, your output will be 20 plus 5. That is 25. Fine. So in this way, during whole of the positive half, your output will be input plus 5. It was very simple. So this is all about positive half, but we are still left with negative half. In case of negative half, the difference will be, no, this will not be in positive, this will be negative. So let's make it negative. This is positive because right now we are talking about negative half the signal. Now there are two signals as before, but there is a difference. Now this battery has no change. It is making your diode forward bias, but this input signal is making your diode reverse bias. And as discussed earlier, whenever there will be more than voltages, we have to see which one is big. Vi is big or this battery is big. Now this battery is 5 volt, but your input, it started from 0 and it is in -1, -2, -5, -10, -20. Till the time your input signal is less than 5, this battery is bigger. Okay, and if you will put KVL, your output will be VO equals to 5 minus, sorry, bad handwriting, so I'm writing it again. If you will put KVL during the negative half, but till the time your input is less than 5, your output will be 5 minus VI. Okay, so 5 minus VI means when your input is 1 volt in the negative half, it will 5 minus 1, 4. When input is 2, 5 minus 2, 3. When input is 3, 5 minus 3, 2. This way, you will get the voltage. But when your input is more than 5, means it is -6, -7, now this input is bigger than the battery, and thus your diode is reverse bias. So it is like a barrier which will stop flow of current, and your input is like disconnected from the circuit, and thus in the output you will get nothing. So this is how you can solve a circuit of series clipper with batteries. You make sure that you are doing some revision, and if you have still questions, you go back and see the previous part of the video, and hopefully you will be able to understand. That is about the clipper circuit. Okay, now parallel clipper are there. These are the examples I have discussed earlier. In this case, this is the input signal, this is the circuit, and this is your output. For the same input, uh, in all these circuits on the right side, this is the output for circuit, this one. So please make practice of this, and if you have any questions you can ask me. Do you want me to do solve something from here? I can help you. If you have any specific question, then you can ask me, I can discuss with you. Yes, all of you. Any questions, anybody? Now let us choose one example. For example, let us talk about this circuit. Okay. Now I'm going to discuss this circuit. Can anybody tell me it is a series clipper or parallel clipper? Among you, anybody is there who can tell me it is a series clipper or parallel? The answer will be, it will be a parallel clipper, because your diode, see the position of the diode. Your diode is parallel to the output, thus it is a parallel clipper. But since we have got a battery also, the complete correct name will be biased parallel clipper. Fine. So now let us discuss this. Now in this case, again, as our signal is having two halves, to make the calculation simple, I will there will be a small change. Your actual input is a sine wave, but I will discuss how much. I will discuss how your circuit will behave. Your input is square wave. Let us, like previous example, let us assume it is 10 and minus 10. Fine, and let us see how your circuit behaves. Now your signal has got two parts, one is positive, one is negative. We will do step by step. For example, in case of positive half, it will be plus, it will be minus. Now you have got two signals your diode is going to get. One is input, which is 10, and this diode we don't know, let us assume it is 5. Let us assume it is 5. Now if you can see, then this is N side of your diode, this is P side. So your input value of 10 volt is making your diode reverse bias because this input is positive and this is N, and this battery is making forward bias because P is getting positive. Now which one is big? Your input is 10, so it is big. It means your diode is reverse biased. If your diode is reverse biased, means this it is like open circuited. Always remember that if your diode is open circuit, this battery presence doesn't matter. It will like you will get its battery is not present because diode is open circuit, so it is not having the part. So thing is, your output and input will be same. So if your input is 10, your output will be same 10. Now if you will talk about negative half, your signal will be opposite. Now in this case, your diode is forward bias, thus it is short. So how much is the voltage? Voltage is between these 2 points, and since this diode and battery is parallel to the output, so these two are parallel, and diode is like short, so voltage between these 2 points is 5, so your output is also 5. So you will get your signal like this. It is 10 and it is 5. Okay, now still we have not solved our questions. In case of our circuit, then our input is this. So we will do it again. Our signal has got two halves, positive and negative. So let us start from positive half. In case of positive half, as discussed earlier, this is N and this is P. Your input is making your diode reverse bias, and your battery is making forward bias. Now your input is not fixed. It is starting from 0. It is going till Vm. So for example, let us take this is the point when it is V. So till the time your input is less than V, your diode is forward biased because this battery is stronger. Then that is short, so your output will be same as this battery. But once your input is more than a battery or more than V, your diode is now reverse bias. Reverse bias means open circuit, so your output is same as input signal. Okay, but if you will talk about negative half, in case of negative half, it is negative, it is positive. Now both of these signals, whether it is input signal or this battery, they are making a diode forward bias, so it will be like a short. If it is short, your output is parallel to battery. If it is V, your output will be also V. So this is how you will get. So I think it is clear. Do you have any questions? That is all about Clipper. Now, in very brief, we will talk about clamper. A clamper is an electronic circuit in which we move move our signal up or down. For example, in this circuit, for this input voltage, this circuit is giving this output where your signal is clamped in the negative part, so only negative part is there in your output, so it will be called as negative clamper. You have shifted your signal in the negative part of the signal. Okay, see this another example. This one was simple clamper, but here this one is called biased clamper. Why bias? Because we have got a battery. Now in this case, your signal was input signal was between 20 and minus 20, but you have shifted up, not completely, by 10. So it was upside 20 plus 10, 30, and in the negative part it was 20 minus 10. It will be 10 in the negative half. So this is how we have shifted up, but not completely. These are the examples or uses of clampers. So let us discuss this simple example. In this circuit, whenever you have got a capacitor, you understand that this is a clamper. This is the basic difference. In case of clippers, we don't have a capacitor, but in clamper we do have. So there is a step-by-step way to calculate easily. And whenever you got a circuit for clamper, remember that always start when your diode is forward bias. Now your signal has got two parts. Let's talk about positive half. It is positive, negative. This is P, this is N. Your diode is forward bias. The diode is forward bias means it is short. And now your output is parallel to diode, so voltage in the diode is same as output. And diode is short means 0 volt, so your output will be 0 volt. Before jumping to the negative half, you have to solve how much is the voltage in this capacitor, because you know how a capacitor behaves. If you give a voltage, it starts charging. So how much is the voltage in the diode, capacitor, we can know by KVL. Here we are talking about positive half, so we know voltage here will be V. And how much is the voltage in capacitor? Let us put KVL in this loop. We don't know right now, we assume it is plus minus VC. I have assumed this. The diode was short, so here it is 0. So no need to write. Let us start KVL writing negative minus V. Why minus? We started in a clockwise direction, at first negative, so minus V. Plus voltage in the capacitor, we have assumed it is VC, so we have to write VC equal to 0, because you know voltage in the diode is 0 because it is forward bias. So VC will be how much? Minus will be here, plus V. So voltage in the capacitor also will be plus V voltage. Fine. Now we'll talk about negative half. Whenever you will talk about negative half, always remember that voltage in the input changes suddenly at this point, very fast. It will change from V to minus V. But capacitor will not change so suddenly. We have just solved that voltage in the capacitor is VC. Now if you see your diode, this is P, this is N. If you see negative is voltage is on P side and positive voltage is on N side. It means your diode is reverse biased. If it is reverse biased, it is open circuit. So how much is the voltage? If it is open circuit, now you have to consider about this loop. Okay, and voltage in the resistor is VO. Now let us put KVL in this, and you know your voltage is how much? V. So let us write KVL. It will be plus V. Why it will be plus? Because we are starting from this point. Plus VC, and you know VC voltage is also V. We have solved before some time. Plus VO equals to 0. Thus VO will be how much? Take these voltages on the right side, will be minus V minus V. It means it will minus 2V. So minus means on the negative side of the axis, and value will be 2V. And earlier we have solved for positive height is 0. So this is the way you can solve your circuit. It is a bit tricky, but